So with point number 5, let's think about actually what that means. A dot B cross C, which we call the triple product. So if we have a U dot V cross W, how could we calculate this? Well, in fact, if you think about what our determinant with our I, J, and our K, if we have a U instead, we could calculate this triple product just by also creating a determinant of U1, 2, 3, V1, V2, V3, W2, W3, and calculating the determinant there. So a question could be, what is the purpose of this triple product? And in fact, we have a theorem. Just as two non-parallel, non-zero vectors span a parallelogram, three such vectors, which are pairwise non-parallel, or in other words, non-coplanar, they will span a parallelepiped, which I've created right here, given A, B, and C. The volume of this parallelepiped is the volume of this parallelogram times the height. Well, we already know the volume of the base, which is just going to be the magnitude of A cross C, and we can find H with a little bit of geometry. Given the angle between B and A, here, in this case, we can say H is going to be the magnitude of B times cosine of theta. So the volume is, just remember, A times H, which would just be the magnitude of A cross C times the magnitude of B cosine of theta, absolute value. Which, in other words, this is just the absolute value of B dot A cross C, given this example here. The triple product allows us to be able to calculate the volume of this object here. It can tell us whether or not three vectors are coplanar, because if the volume of this parallelepiped would be 0, then one of the vectors has to lie in the same plane as all three, because, or is parallel with one, because that would make either the height or the area equal to 0. So we have a theorem for this. Non-zero vectors u, v, and w are coplanar if and only if the triple product is equal to 0, which makes sense from our example of the parallelepiped. So let's determine whether or not these three vectors are coplanar. So we do u dot v cross w, which we set up our determinant of 1, 5, negative 2, 3, negative 1, 0, 5, 9, negative 4. So we do 1 times the determinant of 1, 0, 9, negative 4, minus 5, 3, 0, 5, negative 4, plus negative 2 times the determinant of 3, negative 1, 5, 9. Well, we have 4 minus 0, so we get 4 here, minus 12, negative 12 minus 0, so negative 12 times negative 5 would be plus 60, and then we get negative 2 times the determinant here, which would be 27, minus negative 5, which would be 32. So we get minus 64, which this is equal to 0. Therefore, the vectors are coplanar.